All right, everybody, time to talk about intermolecular forces and physical properties. One physical property is boiling point, and it is influenced by intermolecular forces. We have to review the three types of intermolecular forces, and what are they? Yes. So the weakest intermolecular force is a London. We can go London dispersion forces, van der Waals forces. They're all good. My favorite though, translate to, also known as, that's what AKA is, temporary dipole. It's constantly in flux, happening very quickly, going back and forth between pole states. And then we have the one that's called dipole. Put that one in blue. Also known as dipole. I like that one. I want the word dipole in every answer. AKA dipole. And then you told me the strongest interaction between molecules is a hydrogen bonding. So there's a lot involved in what you just said. And I'm going to start with the thing that I think is the single largest mistake in chemistry teaching history. The name hydrogen bonding. The person who did that threw people behind in their learning, and it made it more difficult. You start thinking it's a bond. Of course you have to think that. It's in the word. It's not a bond. It's an intermolecular force. These are like 1/20th the strength of bonds. Now you're implying they are in the same order as bonds, and they're not. Okay? The forces holding a molecule together, that's bonds, right? Those are strong. Molecules aren't falling apart spontaneously, right? Intermolecular forces are just the forces holding molecules close to each other. You start warming them up, they start moving faster, and they overcome those forces if you have enough energy, right? And the energy is not as much as doing this, breaking a bond. No. You're providing it with a lot less energy to get this molecule away from this molecule. Right now, they're just doing this, and then you have a little more heat, and boom, they're apart from each other. You overcame their intermolecular forces. Okay. Hydrogen bonding, also known as, I got to get dipole in there. Extreme dipole. And I am going to sneak in what you mentioned because it's very important. H must be covalently bonded to NO or F. And I have to explain why, but I really shouldn't. Is hydrogen in a polar bond if it's bonded to something with similar electronegativity? No. All I'm saying is when it's bonded to one of the elements with the three highest electronegativities, it is now polar enough to interact with other atoms in another molecule, only the atoms called N, O, or F, to form what's called a an extreme dipole called a hydrogen bond. Okay? And there's two factors involved why hydrogen bonding is so much stronger. One, that bond is one of the most polar bonds you can have, O bonded to H. But really polar is F bonded to H. And hydrogen is so tiny. You can get those molecules much closer together when it's a smaller atom, right? Replace that H with a C, and now you physically can't get them as close because it's now a bigger ball, right? They start bumping in. So its size and the difference in electronegativity is what contributes here. Now, you're learning organic chemistry. you're learning functional groups. Let's group this according to functional groups. What types of intermolecular forces are present? So I'm going to make my notes bigger. We're not answering this question. In fact, maybe my goal is to do the introductory lecture, and we don't even get to the answer, and then we do the same question at nighttime. And you got to wait till then to get the answer. We'll see how it goes. Because I just had an idea for a good lecture item that I don't think exists anywhere. We have force present. We have functional group and force present. Sorry, I'm working this out in my mind here. Functional group, alkane. And we're going to use short forms. Al, DD, and HB. Okay? Alkane is just a hydrocarbon without any pi or ring. Even if it had pi or ring, it doesn't change the answer here. What force or forces are present? London, and that is the end of the answer, right? L only. Okay. Now to get into the 8 functional groups, we have aldehydes and ketones. Aldehyde, ketone. What do they both have in common? We have a word for it. Carbon with double bond to oxygen has a word. Carbonyl. I know it's spelled carbonyl. Hey, why is this true? Why did I put the delta plus and the delta minus? It's a polar bond. How do you know it's a polar bond? Difference in electronegativity, delta En, 3.5 minus 2.5. That is a polar covalent bond by definition. Difference is 1. Anywhere between 0.5 and 1.9 in some books, 1.7 in other books, polar covalent bond. So it's got L, but it has DD. Every molecule has London, you're going to see with these notes. That's just given. If you have electrons, you got London forces because the electrons are constantly shuffling. We may not get to the question. Are there any other functional groups that have a carbonyl present? Wow. I actually wrote something and it ignored me. Ester. I'm also going to put tertiary amide. They all have carbonyl. There's a reason why I didn't put secondary and primary. I'll put it now. So let's get some lines going here. You have to look at their structure, people. Oops, didn't want that. Nice line right there. Nice line right there. Primary, secondary, amide, or amine. They all have London. Carbonyl with a NH. Primary and secondary have at least one H. Tertiary has no H's on the nitrogen. You just told me if H is covalently bonded to N, there's another force also present. DD and HB.
Can we put the aldehyde?
We have aldehyde already in the cat. No, there is no OH in the aldehyde. You are, in your mind, you went CHO as a short form, and in your mind, you connected the H to the O, and that doesn't happen. CHO is a short form for carbonyl with H attached to C, does not qualify for hydrogen bonding candidate. Carboxylic acid does. We'll put that next. And alcohol. Okay. Why don't we just keep adding to the list? Carbox, acid, and alcohol. They all have hydrogen bonding, dipole, and London. Alcohol, I'm not going to put there. It's not a lie. But the carbonyl is what gave the dipole. So here's the deal. Alcohol, any alcohol. Primary, secondary, tertiary. Alcohol. London and HB. There's no carbonyl for the dipole. And you do know HB is just an extreme dipole anyway. So yeah, it's got a dipole, just a strong. I don't think we have ethers on here, but I'm going to put it right here. Ethers. I know you're saying there's carbon bonded to oxygen, right? Isn't that a polar covalent bond we just said? Yeah, but they're somewhat canceling each other. Here's your ether, right? The dipole goes like this and like this. The right cancels the left, but they both are a little off, aren't they? So it's like such a tiny dipole in an ether, we count it as 0. Okay? It's so tiny we count it as 0. So it gets mixed in with alkanes and tertiary amines. You'd say, wait, tertiary amines got to be polar? No, a carbon-nitrogen bond is borderline polar anyway. 3 minus 2.5, that's not very polar. And there's no H's on the end. It's tertiary, right? What are the 3 bonds to nitrogen if it's tertiary? The classification system tertiary means the nitrogen has 3 bonds to carbon. There's no H's on nitrogen. There's no hydrogen bonding. End of story. That's got all of our categories. We'll start the video for the last part. That's just a get ready for the question. And in the next video, we'll do the question.